Okay, so having made the variable LC or delay line circuit with the long tube and the coil, I found that the millihenry was too small. Basically, it's not to something like 0.05 or something millihenry, isn't it? It's very, very tiny. So I started designing this in SketchUp yesterday, and basically it's very simple. There's not the wire. You have to. I wound the core so that the windings on the inside were tightly packed together, so they're very close together, so there's no gaps. And then and then it was a process of bonding all of the wires in place with super glue. And then I had to file it using a round file going around the inside to take off the enamel of the copper wire so I could make a contact surface area. And then I 3D printed this little core. Actually, I'll pop it out because it's not easy to get back in, but I'll pop it out so you can see it. So I made this little thing with a contactor, and the contactor is basically a bit of ordinary nickel stuff you get in battery tabbing, just ordinary nickel. It bends, so it's not very springy. There's a certain amount of springiness in it. It has a certain amount of springiness in it, which is ideal because I don't want much pressure on these windings anyway, and I think that there's enough springiness in this material to do the job. Because it worked on that, so why won't it work on this? So this basically pops inside the core, and if you look at the toroid, you'll notice that the wire inside has been, I filed it so there's no insulation on the windings. But each individual winding is separated by the super glue anyway, so getting this back on here is a bit fiddly. One of the ways I do it is to get a piece of paper, a bit of greaseproof paper, and I basically put it on like that, and I put it over the top so that we can get a nice transition between when I put this bobbin on, and then push it on like this, and take my paper out like that, and there we have it. And then I've got this cap that goes on top when I'm happy with it. So there's a cap that I've got to bond on there, and I'm not going to stick it on yet because it is going to be literally sealed between these two plastic caps like that, and then I'll literally attenuate it by turning this. So for the moment I can just turn it with this bottom one. So let me bring my meter in the shot, and then you can see, oh, my wires are all tangled up again. Still full of cold. So I've been trying to test it to make sure it's going to be working okay before I actually stick it together again, because it would mean, well, I was thinking about using a nut and bolt like last time, but the trouble using nuts and bolts is that they tend to slip. Actually, I can use a nut and bolt, of course I can, because the this plastic here is bonded onto this plastic here, so it's not going to affect it. So yeah, I can still use a nut and bolt through there. But I used a piece of tabbing, a very thin piece of tabbing. I've purposely left the hole too small so that when I push the nut and bolt through there, the bolt will force the hole to the right size, so the thread will make a good electrical contact with that. Then I can have on the back surface there, I can have a little washer, which is this washer here, and I'll have a little wire soldered onto a battery tabbing connector, so that'll be my center core. But for the moment, let's see if this actually works. I don't know if you'll be able to see my meter. Actually, if I prop it like that and rest something underneath there, that might work. So let me just connect my meter to this thing. So the red, I'm just going to connect the red clip onto this here. Hopefully it'll stay on. I'm just going to hold the probe on the middle core, and that's what we have at the moment. We're just reading DC resistance, not inductance, because it's too much. It's too fiddly to try to show you that. So now all I have to do is turn the middle core relative to the toroid, and you should see the DC resistance changing as I turn it. Actually, how do I do this? I have to hold it with both hands. Right, can you see the meter? Yeah. Right, let's turn it. There's a few dropouts on there, but it's not bad. It's when it goes in between the windings. There's still a bit of insulation on some of the... Oh, I know what I'm doing. I'm not pressing it on far enough. It's not on properly. Right. Right, it must be... Where am I? Oh, my probe is slipping as well. Let's just turn this. We should see the resistance change. I can't see the meter right now. Hang on. It's going down. I must be at the in between the two ends there. 0.6. I must be at the end there. I'll go all the way around. It wants running in 0.7, 0.8. Oh, I'm stuck on something. It's stuck on something. Oh, let me see. Oh, I'm at the end of the track, maybe. Yeah, I'm at the end of the track. Because, well, it isn't a track really, but when it gets to the part where the two windings start or end, there's a bit of a hole there, and it gets stuck in there. So it goes up to between 0.8 ohms and about I'm at the end again. 0.5, 0.6. Yeah, it works anyway. It works. It just needs running in a bit. So basically, where the two wires join together, where they start, the start point and the end point, if it gets in that hole in the middle, it kind of gets stuck, which is alright, because that's the end of the track really. But yeah, it will turn all the way around till it gets to that point, and then it stops. So it's just like a normal potentiometer. And that's my variable inductor. That is literally 0 millihenries to 76 millihenries. It's 76 millihenries, that is, believe it or not, which is pretty big. And that's going to give me plenty of attenuation. He just wants running in a bit. Clean the contacts and the... You see this little piece of metal here? This contactor here has to be held in place, and it keeps moving around at the moment. As you can see, that's why I'm getting intermittent contact. It has to be sandwiched. It has to be pressed in, because the back tension of the windings pressing against the contactor on the end, that contactor springiness is pressing against this contactor here, and if this one is moving around, then I get intermittent behavior. So that has to be sandwiched between this plastic and the bolt that goes through it, and then it should work great. So I will try putting a nut and bolt on it and we'll test it properly. And I have to find a nut and bolt that's long enough though. That's the only issue right now, is finding something that's long enough to go all the way through there. I'm not sure if I've got something long enough. I might have. If not, then I'll have to use a bit of, I'll improvise. I'll use a bit of steel, and I've got plenty of bits of steel that will fit through there, and I'll have to bash the ends over or something, or glue it in place or something. I don't know yet, but I'll see if I've got a nut that's gonna, a thread that's gonna go through there. Let's have a look. Might as well have a look in my nut bag. Let's move this meter out of the way. Right, so what have I got in here? Anything long enough. These little ones might not be long enough. Probably not. I'll just maybe it might just actually, if I recess that will fit. So if I countersink this, yeah, if I countersink the knob end, this end, make the hole a lot bigger at the start, then this will reach. It's just almost just coming through that end. So that'll work. So I have to countersink it with something. Let's find a bigger drill. If I use the 3mm drill to try and ream that hole out a bit bigger. I'm just going to do it by hand. I'm not going to use power tools on this because I made a little slot for me to make it easy to turn it. I was thinking about putting a knob on it, but I decided I wanted to keep it low profile really. Oops. Also, it's not something you want to keep twiddling about once you get it set right. So if I just roll this out a bit, like this. I need to go upsizing. Somebody is messaging me. Who's messaging me? Oh, it's just my daughter. I'll have to go and check the message and end the stream in a minute. Oh, hope she doesn't ring me while I'm live streaming. Oh, that would not be good. Right, so I'll use this 4mm drill to countersink that hole a bit bigger. Right, hopefully that that bolt will fit now. Looks like it will. Well, it's not going through the metal, which I didn't think it would because it's a tight fit. So what I'm going to have to do is I'm going to have to take it through from the other side to begin with. Actually, what I'll do is I'll get my file. I've gone bent the contactor now. I'll just get my file, get rid of that shaving rubbish. I'm going to have to make it a bit bigger because it's too tiny for the nut to go through the bolt. Yeah. So let's try it, fit it. Oh yeah, that's going to work now. Right, so if I get my bolt in. Sorry, I'm trying to do this on camera and I keep forgetting. I might have to recess that a bit more because I don't think it's enough of it going to stick out. Oh, maybe. Well, it's recessed well enough. Yeah, I think that's going to work. So, if this bit of metal doesn't make contact with that bolt, I could always make another tin thing or stick this steel washer on or something. But let's just see if I've got continuity. Between that and the bolt. Yes, I do. And it's reading 0.6 of an ohm, so it's definitely connected really well. So that works. Now I'll put my end cap on. I'm hoping there's enough on me to put the nut on. Yeah, there is just enough. But actually, I won't have enough room to put the washer on as well. So I'm just going to leave the washer off. Anyway, I want the nut to be super glued on there anyway, so it doesn't start spinning and coming apart on me. Super glue is not too bad if you super glue it and you want to take it apart again. All you have to do is heat the nut, get the soldering iron, heat up the end of the thread, and it breaks the super glue bond. So it's not permanent, it's semi-permanent. There you go, you watch me finalise it and put it together. So I'm just going to hold that in pliers. Tighten that up. The whole thing's going around while the nut's stationary. I want that nice and tight. Shouldn't be too tight on the thing because I spaced it so that it shouldn't pinch it too much. Let's check it. Does it go around? Yes, it does. It turns. Even though I tightened it pretty well, it does turn, look. We have it. We have a variable inductor. There's one thing I've forgotten, and that is that the middle conductor, I need a tabbing on there where I can solder a wire to it. So I'm going to have to make sure I can get a thin. Actually, I'll make the tabbing out of that stuff. I'll just make another hole in some of this, make my own battery tabbing. Sorry, not battery tabbing. Use my own battery tab material to make a solder tag for the middle leg of the variable controller. But in the meantime, let's do another check. between these windings and the middle core. Yeah, it's beeping. It works. So one variable inductor, not to 76 millihenries. Which is going to be a lot of fun when I put it on my device, on my generator project, and play around with this. I'm going to have a lot of fun with that. But I'll tell you what else is missing. I don't know if you've noticed, but this thing is going to be floating about. So another thing I really need to do is make a little clamp, like a little thing that will go around the toroid like that, and to give me a PCB mount to mount onto the circuit board so that it stands upright. That's the other thing I need to make, really. I thought, well, I'm going to just test this to see if it works first. I don't want to start over designing it only to find out it's not going to be practical. But I had to do a lot of the stuff under my watchmaker glasses. Basically, I had to look under there to do the actual contactor, and it was a hell of a fiddly job. I'd used a pin, and I used to use some really tiny drills to poke around in this slot to bend the connector legs out. So it's basically shaped like the omega symbol. So it's basically shaped like the omega symbol, you know, like a upside down U with legs that come out, and those press against that contactor, which comes in contact with that little bit of tabbiness on top. And that forms the middle conductor leg. Anyway, I'm going to have to go because my daughter's probably wanting she's doing something online. And so, yeah. Not bad for an early prototype. I mean, I've basically just done that one, and I did this one the other day, yesterday. So I've got the longitudinal type one, and I don't know if that's the right word for that. Yeah, I think I'll call it the rod version and the circular version, the rotary and the slider version. That's it. Anyway, that's it. Thanks. Bye.